We're going to talk about how to find z-scores, but before we get started, you want to make sure you have your z-score table, which looks like this. It is a 2-page document, and it is found on the class website. So if you don't have a copy of that, make sure you get a copy. And then once you have that set, we will start our notes. So first thing we want to talk about in our notes is the z-score and how do we actually find it. So when we are trying to find a probability for a range of values that cannot use the empirical rule, and our empirical rule is that 68, 95, 99.7 rule, we have to calculate a z-score. And in order to calculate that, we're going to use our mean and our standard deviation. All right, here I'm going to give you your z-score formula, and you do not have to memorize it, but it is your z-score is equal to your x minus your mean divided by the standard deviation. You do want to write this down so you have it going forward, but it will be given to you on assessments. All right, let's go down here to example 1. So suppose the mean height of adult men is 69 inches with a standard deviation of 2 inches. The mean height of adult women is 64.5 inches with a standard deviation of 2.5 inches. Which is considered taller within their respective gender group? A man with a height of 74 inches or a woman with a height of 67. All right, so first off, we have, let's do this. We have an adult man, has a mean height of 69 inches and a standard deviation of 2 inches. And then adult woman has a mean height of 64.5 inches and a standard deviation of 2.5. So an adult man, a specific man that we're going to find a z-score for is 74 inches tall, and a specific woman is 67 inches tall. Okay, so to find our z-score, and remember z-scores are equal to our x minus our mean divided by our standard deviation. So what percentile group is the man in? In order to figure out the percentile group, you first need to find the z-score. So let's plug that into our formula. So my z-score is equal to something minus my mean for the adult man. So my mean height is 69 divided by my standard deviation for the adult man, which is 2. Now, the x value that we use is the number for the particular man. So in this case, 74. So then all I have to do is go to my calculator. See if it'll turn on. All right, and we would do 74 minus 69, and then divided by 2 gives me 2.5. So I have a z-score of 2.5. Now it's easier to look up our z-score on our chart when we have 3 numbers. So I'm going to say that my z-score is really 2.50. So I'm first going to look up the first 2 numbers. So the 2.5. All right, so if I go to my chart, on the side you can see there's a bunch of 2-digit numbers, negative 3.4, negative 3.3, so on and so forth. I'm looking for 2.5. So I'm going to go down. Okay, I found 2.5. Now, if I look back at my notes, my third number is 0. The third number goes with the top numbers up here. So I have my 2.5, and then I go over to the 0 column, so 2.50 gives me 0.9938. So that is the probability that matches the z-score of 2.5. So 0.9938. In order to figure out the percent, all we have to do, you can either multiply it by 100, or we can move the decimal, and we get 99.38%. We're going to do the same thing over here with the woman. So first I need to find my z-score for the woman. So my z-score is equal to something minus the mean. The mean for the woman was 64.5 divided by my standard deviation for the woman, which was 2.5. Remember, x is talking about a specific data value. So in this case, we're talking about a specific woman height. So we're going to use 67. And again, you go to your calculator, you do 67 minus 64.5, then divided by 2.5, and we get a z-score of 1. Remember, z-score, it's easier to look up on the chart when we have 3, so we're going to turn this into 1. My z-score is going to equal 1.00. So the first part I'm going to look up is the 1.0. So if I go to my chart, I'm looking on the side, there's my 1.0. My third number was also 0. So if I go 1.00, I now get 0.8413. So my probability is 0.8413. Change it to a percent, 84.13%. So who is taller in their respective groups? The man is taller in his group. Part B, you can find the z-score for your own height. I'm not going to take time to do that, but you're welcome to check in with me to see if you did it correctly. So if we go to the next page, example 2 says a normal distribution has a mean of 108. So that is a key part. I have a mean of 108 and a standard deviation of 5. And this is asking us to find the standardized value for each data point. Now your standardized value is just asking you to find your z-score. So remember, in order to find the z-score, we say z is equal to my x minus my mean divided by my standard deviation. So part A, we have our x value is 100 because our mean and our standard deviation are given to us. So all we have to do is use our formula to find the z-score. So z is equal to 100 minus 108 divided by my standard deviation of 5. Again, we go to our calculator, we do 100 minus 108, and then divide that by 5, and we get a z-score to equal negative 1.6. And if you want to say negative 1.60, that's fine, but we can leave it with 2 numbers since we're not looking anything up right now. And then same thing with part B, we're going to just plug it in. So my z-score is equal to 117 minus 108 divided by my standard deviation, which is 5. So my z-score is equal to, and put this in your calculator, and you should get positive 1.8. All right, so if we look at example 3, 3 is now asking us to find the probability. 2 was just asking for the z-score. 3 is asking for the probability, which means we are going to have to use our chart. And for example 3, we're going to find the probability of falling below the following given z-scores. So if I have a z-score of negative 2.7, I'm going to say negative 2.70, so it's easier to look up. So I'm going to go to my z-score table, and I'm first going to look up a negative 2.7 on the left. Negative 2.7. Negative 2.7. Okay, I found my negative 2.7. Sorry. And then it was negative 2.7 and then 0. So that gives me a probability of 0.0035. So I have my probability of 0.0035, and that's it. So I'm going to do one more. I'm going to do part B with you. You can try C and D on your own and then check in with me, or you can check the answer keys on the website. So part B is negative 0.08. So I'm first going to look up the negative 0.0. So I'm going to go to my chart. I'm going to find negative 0.0, which is all the way down here. So negative 0.0. All right, then that third number was 8. So 8 is this column. So I'm going to go to the very bottom, and that gives me 0.4681 is my probability. 0.4681. And again, I'm going to leave C and D for you to do, but you're welcome to do them on your own and then check the answer key or check in with me. Example 4 is saying to find the probability above the following z-scores. So this is key. Since it is asking for above, we're going to have to do something a little bit different. We can't just go look up a negative 3.2. We have to look up the opposite. So instead of looking up negative 3.2, I'm going to look up positive 3.2. And then I'm going to put that 0 on the end so I have my 3 numbers. So I'm first going to look up the first 2 numbers of 3.2. So positive 3.2. Okay, it's right down here. So 3.2, and then 0 is that first column. So 0.9993. So 0.9993 would be my probability of above a 3.2, negative 3.2. But remember, I looked up the opposite. So how do now I need to find the probability above a positive 2.85. Since it says above, in order to look it up, I need to switch to a negative 2.85. So I'm going to look up my first 2 of negative 2.8. Negative 2.8. Close to the top up here. Okay, so here's my negative 2.8. And I wanted negative 2.85, I believe. Yes, negative 2.85. And that gives me this guy. So 0.0022. And that would be my probability, 0.0022. Again, I'm going to leave C and D for you to complete on your own. Above is the only time you have to change the z-score, and that's really important. So make sure you don't forget that. Example 5, finding the probability in between the following z-scores. So first I need to find the probability that matches each z-score. So I have a negative 3.04. So I'm going to go to my chart, and I'm going to look up negative 3.04. So 0.0012. So that is the probability that matches with the negative 3.04. 0.0012. I also need to find the probability that matches with the negative 0.56. So again, I'm going to go here. I'm going to look for my negative 0.5. And then go over to the 6. And I get 0.2877. So this one gives me 0.2877. Now, in order to find in between, I have to subtract my two probabilities. So I'm going to take 0.2877 and subtract 0.0012. Go to my calculator, and I get 0.2865. Now, if you want to try B on your own, you can pause the video and then check back in. I am going to go through B just like I did A though, so if you're still a little confused. So I'm finding in between. I have my z-scores, so I need the probability that matches them. So I'm first going to look up the negative 1.17. So we go to our chart, let's find the negative 1.1. All right, and then we go over to 7, and I get 0.1210. So we got 0.1210. Do the same for the 2.23. So I'm going to look up 2.2 and then go over to the 3, and I get 0.9871. All right, now that I have my two probabilities, in order to find in between, I'm going to take the bigger one, so 0.9871, subtract the smaller one, 0.1210, put that in my calculator, and I get 0.8661. So that's how we find probabilities that are below, above, and in between certain z-scores. Now we're going to start to put it all together. So with example 6, Trudy can run 10K races, which is 6.2 miles, with a mean time, so that is key, so a mean time of 55 minutes and a standard deviation of 4 minutes. The distribution of her 10K times is approximately normal. What is the probability she will run a 10K less than 53 minutes? What percentile would she be in? So in order to find a probability, I first need my z-score. And again, remember that my z-score is my x minus my mean divided by my standard deviation. So let's find that first. So my z-score is equal to my x. In this case, my x is 53, minus my mean, which is 55, divided by my standard deviation, which is 4. So I can put all that in my calculator, and I get a z-score of negative 0.50, because remember, I want those three numbers. Now what I want to look up is the probability that is less than that. If something is less, that's like saying below, which means I don't have to change my z-score. I can just take this and go right to my chart. So I'm looking up a negative 0.50. Negative 0.50. So here's my negative 0.50. And that gives me a probability of 0.3085. So my probability is 0.3085. Then it's also asking what percentile it is, what percentile she'll be in. So all we have to do is move our decimal, and we get 30.85%. Part B, what is the probability she will run longer than 53 minutes? All right, so I first need to find my z-score. So I'm going to take my z-score is equal to, in this case, I'm using 60. So 60 minus my mean, which is 55, divided by my standard deviation of 4. So once I have all that, I can go to my calculator, and in this case, I get a z-score of 1.25. Now this question is asking for everything that is longer than 60 minutes. Longer is like saying above. And since we're dealing with above, I can't look up 1.25. I actually have to look up a z-score of negative 1.25. So I go to my chart, I have my negative 1.2, and then I need to go over to 5, and I get a probability of 0.1056. So 0.1056. And all it was asking for was the probability, so there is my answer. Now, part C, what is the probability she will finish between? So between 50 and 60, which means I need a z-score for both 50 and for 60. So I'll set up my formula. My z-score is equal to 50 minus 55 divided by 4. So that will give me a z-score of, after I put it in my calculator, I get negative 1.25. And then I'm also going to find the z-score for 60. So 60 minus 55 divided by 4. And if you look at part B in blue, we just did that calculation and we got a positive 1.25. Okay, so now I have my z-scores. They are negative 1.25 and positive 1.25. In order to figure out the probability in between, I need a probability that matches each z-score. In part B, I already looked up a z-score of a negative 1.25 and I got 0.1056. So I'm going to go to my chart and look up a positive 1.25. So let's go to our positive 1.25. Here's positive 1.2 over to the 5, and we get 0.8944. Now, in order to figure out in between, we just subtract our two probabilities. So 0.8944 minus 0.1056. We go to our calculator, type that in, and we get 0.7888 as our probability of falling in between those two times. All right, so now example 7. I'm not going to do problem C or D. I am going to do A and B. Now A and B are different than what we have been doing, and they're a little bit harder. So make sure you pause the video or have to rewind the video if you get a little confused. So the Wilshire Adult Intelligence Test Scale is composed of a number of subtests. On one subtest, the raw scores have a mean of 35. Okay, so that is key. Mean of 35 and a standard deviation of 6. Assuming the raw scores form a normal distribution, what number represents the 65th percentile? So we're actually starting at the end and we have to work back to the beginning. So I know that whatever this value is, it falls within the 65th percentile. So 65%, and if I change that to one of those decimals, it would be 0.65. So I have my probability of 0.65, which means I can go to my z-score chart. And I'm looking all through here for a number that's close to 0.65. So if I look in here, I've got 0.6591, 0.6554. It looks like 0.6517. That's the closest I can get to just 0.65. Well, what z-score matches up with 0.6517? Start over on the edge, and I get 0.3, and then I pick the number at the top, 9. So 0.39. So that means that for this problem, I have a z-score of 0.39. So if I plug everything I know into my z-score formula, I get 0.39 is equal to x minus my mean, which is 35, divided by my standard deviation, which is 6. Now all I have to do is solve for x. So the first step here, multiply by the bottom of your fraction. So multiply each side by 6. That cancels out our fraction. And we get 2.34 is equal to x minus 35. And then if we add 35 to each side, we get our x value of 37.34. And that would be our answer for part A. So we're going to do the same thing for part B. What number represents the 90th percentile? So we're saying that's going to be 90%. Change it to a probability of 0.90. So then, once I have my probability of 0.90, I go to my chart. I'm looking all through here to get the closest I can to 0.90. And I'm going to choose 0.8997 because 0.8997 is a lot closer to 0.90 than 0.9015. So what z-score matches with 0.8997? Start over on the left, so we have 1.2, and then pick at the top 8. So 1.28. So my z-score is equal to 1.28. I'm going to plug it into my formula. 1.28 equals my x value minus my mean of 35 divided by my standard deviation of 6. Multiply each side by the bottom of my fraction, so by 6. Cancels out my fraction. And that leaves me with 7.68 is equal to x minus 35. I'm going to add 35 to each side, and I get x to equal 42.68. Those are the notes on z-scores. Make sure to ask us any questions that you have.